Hi everyone, welcome to the first of our videos for the new online portion of our course. So we'll be starting in with section 10.1, which we get to play around with radicals and radical functions. So first, a little vocab to get out of the way. The general radical expression. This symbol is a radicand. If there's a little number written here, the general term would be n, that is referred to as the index. And here x, or whatever function, that is our radicand underneath the radical. This generally typically would just shorten to being the argument. Different names for the same idea. So the radical expression that you're used to working with in previous coursework is likely just the square root. And the square root is just asking you a question: what number can I multiply 2 copies of to reach the number underneath? So for example, the square root of 0 is 0 because 0 squared does equal 0, or the square root of 9 is equal to 3 because 3 squared is equal to the argument 9. So if I have something like square root of x to the 10th, I'm looking for what can I square to reach x to the 10th power. So remember, a power raised to a power, our shortcut is to multiply. So that would be an x to the 5th that I can square to reach x to the 10th. So the square root of x to the 10th is just x to the 5th. So you want to be careful when they give you something like square root of n to the 64th. Sometimes they'll give you a nice, neat, pretty looking perfect square up there. But remember, you're just thinking back to power raised to a power, we multiply. So our goal is to multiply something by 2 to reach 64. Well, that would be a 32 then. So our result would be n to the 32nd power. And we, of course, will occasionally combine numbers and variables underneath the same radical. So, for example, root 36 x to the 6th. Again, if it's just a simple square root, you're just looking at what can I multiply 2 copies of to reach 36 x to the 6th. Well, 2 copies of 6 would get us back to the 36, and 2 copies of x cubed multiplied together would get us to the x to the 6th power. Now this idea of what can I multiply 2 copies of to reach the number underneath tells us then that if I have square root of 25, again, my goal is something times itself to get to a negative 25. Well, some things that I can try negative 5 quantity squared, but that's negative 5 times negative 5, which is a positive 25, not what I'm looking for. We can try a 5 squared, but again, positive times a positive is also a positive. 0 squared, we saw above, 0 squared is 0, negative squared is a positive, positive squared is a positive. There are no real numbers that I can square to reach a negative number. Later on in the chapter, we'll get to do a little bit more work on that, but for now, they just have us say not a real number. Now, that's not to say that that's the same thing as no solution. No solution, first of all, would be an answer to an equation, not an expression, but second of all, there is a number that will get this job done, just not in the set of real numbers. You want to watch for placement of that negative, though. If I park that negative out in front of the radical, now I'm just asking for the opposite of root 25. Well, root 25 is 5, so that would be the opposite of 5. So the opposite of 5 squared is the opposite of 25. So I'm going to put up a few problems, and what we're going to do with this is I'll just put the problems up. I'll ask you to pause it, try the problems. When you've done the problems, then go ahead and play the video. So right now I'm just going to put a quick 4 of them up. See if you can simplify the expressions. So first one, square root of 121 y to the 16th. Second one, square root of negative 36. Third one, opposite of square root of 36. And fourth one, opposite of square root of negative 36. So go ahead and pause and see if you can simplify those. Okay, welcome back. So our first one, we were looking at what you could square to reach, first of all, the 121. Well, 11 squared would get you back to 121. And y to the 16th, if I multiply 2 copies of y to the 8th, I get y to the 16th. Second one, I'm looking to multiply 2 copies of a number to get negative 36. Right now, all we'll say is not a real number. Again, later in the chapter, we'll be able to say something more than that. Third one, negative was outside of a radical, so I just want the opposite of whatever square root of 36 is worth. So in this case, a negative 6. This one, the negatives don't cancel each other out. In here, I have something that's not a real number, so my answer is just that this is not a real number. So square roots you've likely played with before a little bit. Next we get to play around with our friend the cube root. So just like square is asking you the question, what can I square to reach the argument, the stuff underneath the radical, cube root is asking, what can I cube to reach the stuff under the radical? So a quick definition, cube root of a equals b, if and only if. You'll sometimes see mathematicians abbreviate that as IFF. If and only if b cubed is the same as a. So it's just saying, okay, what can I cube to reach the argument? Let's start with our friend the 0 again. So we have an index of 3 here, cube root of 0. Well, that is still 0. 0 cubed, 0 times another 0 is still worth 0. So 0 is both a perfect square and a perfect cube. If I want the cube root of negative 8, again, that's asking what can I multiply 3 copies of, what can I cube to reach negative 8? Well, if I have an odd number of negatives, I can get a negative, no problem. And 2 by 2 is 4, times another 2 is 8. So negative 2 quantity cubed is worth negative 8, so the cube root of negative 8 is the negative 2. I can multiply 3 copies of negative 2 to reach negative 8. let's see, so we'll try maybe the cube root of x to the 18th. Again, I want to multiply 3 copies of something to reach x to the 18th. Again, we'll think back to that power raised to a power rule. Our shortcut is to multiply them. So since 6 times 3 would get me back to the 18, my result for this would be x raised to the 6th power. We of course can mix and match some numbers and variables with cube roots as well. So if I want the cube root of negative 64, let's say p to the 6th power. I'm looking for 3 copies of something that I can multiply together to get negative 64 p to the 6th. For starters, the coefficient. If I do negative 4 times negative 4 times negative 4, 3 negatives multiplied together would get me back to a negative. And 4 by 4 is 16. 16 by 4 is the 64 we're looking for. So negative 4 is part of our solution. And as far as getting to the p to the 6th, if I take p squared and cube it, power to a power, I would multiply those exponents. I get the p to the 6th. So negative 4 times p squared would be our cube root. So then a couple properties for what we refer to as nth roots. So here n is part of the set. It starts at 2 since square root is as small as we go. Square root, cube root, 4th root, 5th root, etc. So we'll start with a being greater than 0. Greater than 0, in other words, a is positive. And for the moment, we'll let n be even. So the nth root of a even root of a positive number, we can do that. So this is a real number. Now there's no guarantee that it's something pretty like square root of 9 will give us a nice, neat, pretty integer 3. Square root of 7 would also fall under this category. Now since 7 falls between 4 and 9, the perfect squares around it, we know it's 2 point something. But that something would go on forever. So it might be an irrational number. It might not turn into a nice, neat, pretty number like a 3, but irrational numbers are still in the set of real numbers. Same rules. A is greater than 0, in other words positive. N is even. If I take then the nth root of the opposite of a, the opposite of a positive is negative, then we know this is not a real number. So true not only of square roots, but also 4th roots, 6th roots, 100th roots, 402nd roots, etc. Any even root of a negative, you're being asked then to multiply an even number of negatives together and get a negative. Well, an even number of negatives is positive, even number of positives is positive, and any number of zeros is always a 0. So if we switch it up again, a is going to be positive this time, n is odd though. Nth root of a is a real number. And again, it can be something that turns into a nice, neat, pretty integer. Cube root of 8 is just 2, since you can multiply 3 copies of 2 together to reach 8. But since I can multiply 3 copies of negative 2 together to get negative 8, and there's nothing all that special about that example, in general, for an odd index, Opposite of A would be negative. Odd root of a negative is still a real number. And for both of these cases, the nth root of 0 is always going to be 0, whether n is even or odd. So we can do some simplifying, like asking for the, well, let's say 4th root of 16 y to the 20th power. So the index does the talking. I want 4 copies of something to be multiplied together to end up at a 16 times y to the 20th. Well, if I multiply 4 copies of 2 together, 2 times 2 is 4, times 2 is 8, times another 2, there's our 16. So we know there's a 2 involved in the answer. And again, with the variable, think of that power raised to a power rule. You want to multiply these things together and get 20. So the exponent on the y had to be a 5. So the 4th root of 16 y to the 20th is 2y to the 5th. If I multiply 4 copies of this together, I get to the argument. And the next thing we look at is a nice pretty little pattern. We'll start with just square roots. Square root of 3 squared. Well, 3 squared is worth 9, and the square root of 9 is worth 3. No problem. But if instead I tried square root of negative 3 quantity squared, at first it looks concerning. I have an even index, the unwritten 2 that's there, but this quantity inside is not negative. Negative 3 times negative 3 is actually still a positive 9, so we are okay, and that will spit out a 3. Now I can generalize that. If I have the nth root of a to the nth power and n is even, then this will result in just absolute value of a. So the 3, it stayed the same. Negative 3 turned into a positive 3. That's an absolute value idea. If we do this with cube roots, let's try cube root of, again, we'll keep the number small, cube root of 2 cubed. Well, that's the cube root of 8, which is just a 2. So it looks like that pattern is holding from the last one. Again, we'll go with an odd index. Cube root of negative 2 quantity cubed. I'm multiplying 3 copies of negative 2 together. An odd number of negatives is still a negative, so this is cube root of negative 8, which is a negative 2. So for n even, my apologies, n odd, we just did n even a minute ago. If n is odd, if we have the nth root of a to the n, it's just equal to a. I don't need the absolute value anymore like I did with even roots. Even roots is where those negative numbers to an even power kick out positives. And we need the absolute value. If it's odd, we can just spit out whatever the original a was. Alright, so that part is it for 10-1. Let me get your homework going here. So in 10-1, I would recommend 1 to 77, every other odd, 79, 87, 93 to 97 odd, 105, and 107. Okay, that's the end of section 10.1. 10.2 is coming up. Please stay safe, keep your family safe during this, and I will see you again hopefully shortly when this health crisis is over. Thank you. Stay safe. Goodbye.